For number 5, we want to simplify this ratio of powers of 10, 10 to the 5 over 10 to the 3. There's a rule for that, of course, but again, without even worrying about that, just thinking about what these symbols mean, there's nothing wrong with just writing it out. I mean, 10 to the 5 is 5 10s multiplied together, or that's a 1 with 5 zeros. 10 to the 3 is 1,000, or a 1 with 3 zeros. So, it's 100,000 over 10,000. You could think of canceling zeros if you want to. That's like, dividing top and bottom by 10, or just, divide it on your calculator. When you cancel zeros, you're going to run out down here first, and so you're left with just, 100 basically. So that's 100. 100 is also 10 to the 2, of course. So the rule here you can kind of see is the 2 happens to be 5 minus 3, and that's no accident, obviously. I mean, that's always going to work. This will be your zeros here, and that'll be your zeros there, and then when you cancel them out, you're going to have, this minus this left. I've been giving rules a hard time here, but rules, or maybe a better word would be patterns. Patterns certainly are important in mathematics. One thing that patterns can do for you is they let you kind of extend your mathematical ideas into places that you didn't expect at first. For instance, with powers, that's a good example of that. Powers, again, are just a lazy way of showing a repeated multiplication. 10 to the 2 just means 10 times 10, or 100. 10 to the third power means 10 times 10 times 10. 3 tens are 1,000, and so on. That's kind of where you start. Well, how about 10 to the 1? I mean, 10 to the 1 then would be 110 multiplied together, I guess. Just kind of like 110. Well, 10, I guess. I mean, 10 kind of makes sense. But what about lower? I mean, what about, like, say, 10 to the 0? I mean, 0 10s multiplied together doesn't really make any sense. So, does that have any meaning or not? Can we give it some meaning that is going to be useful? Well, it turns out we can, and kind of those rules do play a role. The rule we just saw, and we just did 10 to the 5 divided by 10 to the 3. The rule was, subtract these two powers, and you get 10 to that power. And again, that always works when you divide a big number by a little number. It's a handy rule. 10 to the 8 over 10 to the 3 gives you 10 to the 8 minus 3 is 5, and so on. Well, what if you did, like, say, 10 to the 2 divided by 10 to the 2? If you use the rule, 2 minus 2 would give you a 0. On the other hand, this is just, two numbers divided. We can figure what this is. In fact, this is just 100 over 100. In fact, it's just 1. I mean, 100 pies divided by 100 people is 1 pie per person. So, no question, this has definitely got to be a 1. But if we take our rule from here and just go ahead and apply it, 2 minus 2 would give you a 0, and so, 10 to the 0 is what you would get for that. So it makes sense. It seems like a pattern that 10 to the 0 we should call 1. Basically it's our choice. 10 to the 0 is 1 basically because we say so, but it's what fits the patterns best. If you made 10 to the 0 anything else besides 1, lots of rules for powers would kind of break down, and there'd be a lot of exceptions. It'd be real messy. I mean, this is what kind of makes sense in terms of the pattern. Well, what about going lower, like, say, negative powers, 10 to the minus 1? Well, again, keeping with our rule here, let's say you divide a smaller number by a bigger number. 10 to the 2 by 10 to the 3. So that's 100 pies divided by 1,000 people. That's it's not very much pie. 100 people, 1,000, or 100 pies, 1,000 people, you're only going to get like a tenth of a pie per person. 100 divided by 1,000, that's definitely 1/10 or 0.1. No question about that. But if you also use our power rule, 2 minus 3 gives you a power of -1. So again, the pattern is suggesting that 10 to the minus 1 we ought to call 1/10, and so on, kind of going down. So 10 to the minus 2. Actually, you can think of 10 to the minus 2 as like repeated multiplications of a tenth now. A tenth times a tenth, or 1/100th. 10 to the minus 3 is 1/1000th, and so on.